Moving on to the next and an important property, that is formation of colored compounds. Any compound, a metal or an ion, acquires color due to what? The electron. The behavior of electron towards the visible light. So what happens from the visible light? They can absorb some energy. Because of the absorption of energy, the electron in the lower energy state can get excited to the higher energy state. In that process, it will absorb few of the radiation from the visible spectrum. So while coming down, it will re-emit the radiation. So the color basically which is observed will always be complementary to what is being absorbed. So if they absorb, let's say, some X number of radiation, whatever they will re-emit, it will be always complementary to what is being absorbed. So this is the general fundamental towards the formation of colored compounds. So if we talk about, let's say, copper 2+, what is the color of the cupric ion? Blue. There is a famous compound of this CuSO4.5H2O which is called blue vitriol. So the blue color of CuSO4 is due to Cu2+ ion, and that is why we say the cupric ion is blue colored. Okay. Now the color depends on many of the properties or many of the conditions. One of the condition is the presence of unpaired electron. If I write the configuration for neutral copper, what is the configuration? 3d10 4s1. Remove 2 electrons. 3d9. So copper 2+ is 3d9. 3d9 meaning there is an unpaired electron, single unpaired electron, because the 9 electrons will be entered like this. Correct? So there is one unpaired electron. Now what happens when the color is being acquired? सबसे पहले we have the d orbitals. 5d orbitals, dxy, yz, zx, x square minus y square and z square. These are d orbitals which will be degenerate, meaning of the equal energy. Degenerate means of the equal energy. Now, the metal in the neutral state will always have the d orbitals energy equal, meaning the orbitals will always be degenerate. Now, when it is having a tendency to form any compound, then it will acquire some oxidation number. So let's say it is forming cupric sulfate and hence it acquires Cu2+. And now the unpaired electron will be present in the last d orbital. Next, when there is a incoming ligand, the ligand is the negatively charged anion to which the cupric ion is going to get bonded. So in the presence of the ligand, what happens? This energy level gets splitted up into two different energy levels, which is called lower energy level and higher energy level. This particular concept is called crystal field splitting. Crystal field splitting. So what actually happens in the presence of the ligand, the d orbitals which are degenerate now will lose its degeneracy, meaning it will split it up into two different energy levels in which there will be 3 orbitals at the lower energy level and 2 orbitals at the higher energy level. This is how the splitting happens. Now what happens here, the lower energy level is assigned a name T2G and the higher energy is EG. This particular concept will be explained in much detail in coordination compounds. So when we do the complexes or the coordination compound, the splitting, why it happens and how the splitting takes place, all those concepts will be discussing in detail. As of now, just understand in the presence of a ligand, the d orbitals loses its degeneracy, splits up into two different energy levels, the lower energy and higher energy. In this, I am taking the case of the lower energy as T2G and the higher energy as EG. Now what happens, let's say in the lower energy level, if there is one unpaired electron, so in the presence of the light visible spectrum, it will absorb some of the energy from the visible spectrum. Due to the visible spectrum ka energy absorbed, the electron in the lower energy will get excited into the higher energy level. will get excited into the higher energy level. This excitation is possible because the difference between this energy level is very low, because it is actually being splitted up from the d orbital. So the delta E, the difference of this energy is very small, and it is small enough for the electron to get excited from the lower energy to higher energy. Is that clear? So this excitation is basically called as DD transition. DD transition because it is happening within the same d subshell. Within the same d subshell. Meaning if I talk about the cupric ion, this is the 3d orbitals, and the DD transition is happening within the 3d subshell, and hence I can clearly say that this difference of the energy is very small, and it is also small enough for the excitation of the electron to become possible. So now when it gets excited into the higher energy level because of absorption of some energy, during the de-excitation it will emit the energy, and now the color of any of the ion or the compound is due to the absorbed energy or emitted energy. Emitted. It is, that's why always said to be complementary of what is being absorbed. Now what is the color and how to analyze? For that we have a simple concept given by Munchen. Munchen करके एक साइंटिस्ट था, उसका एक Munchen wheel है, ठीक है. So in the visible spectrum we have the Vibgyor colors. So that Vibgyor can be arranged in the simple form of a star or two triangles, ठीक है. And we say the colors can arranged as like this. So I खाली बीच में रखना है, बाकी Vibgyor इस तरह से arrange करना है. अब concept क्या है? If some ion absorbs orange radiation, then the color which will be observed will be blue. Meaning I can say that the cupric ion actually is able to absorb the orange radiations from the visible spectrum. Hence the color which is observed by the observer will be blue. Similarly, if there is, let's say, yellow and green radiation being absorbed, the color will be somewhere between violet and red. That's why we get different colors based on the different absorption by the ion. The simple concept over here is the colored compounds or the color of the compounds depends on firstly the presence of the unpaired electron, due to which there will be a possible DD transition. The color of the ion will also be dependent on the nature of the approaching ligand. It's not that cupric ion will always be blue colored. Cupric sulfate is blue color because of the approaching sulfate. Because approaching ligand जो है इस splitting को कम या ज़्यादा कर सकता है. If this splitting changes, then even the DD transition का and the absorption of the wavelength will be differed. So obviously the color will also differ. Colorless will have the condition of no unpaired electron. So if there are all the electrons which are paired, the simplest example of that is Zn2 plus. What we have over here is 3d10. Now all the electrons are paired. So if there is no unpaired electron, it will not be able to excite. The DD transition also will not be possible, and hence it will be colorless because it will not be able to absorb any radiation. So if it is emitting everything, it will be Vibgyor ka combination, which is white, meaning colorless. The color of the transition metal compound also depends on the type of the complex and the geometry of the complex. एक बहुत simple example we are taking over here. Let's say we have CuSO4 dot 5H2O. What is this? Blue vitriol. Now in this blue vitriol, we can have the cupric ion which is hydrated, and in the hydrated form it can exist as CuH2O6 2+. What will be the geometry of this compound? After the copper breaks down and it gets hydrated with the water, these are not the same H2O molecules which I have written. So basically जब cupric ion hydrate होता है, it forms a complex or the geometry of the type CuH2O6. Tell me what will be the geometry of this compound, of this complex? Perfect. sp3d2. Trigonal planar
Square.
उसका एक नाम है बाबा. Octahedral, 6 ना. Copper is bonding with the 6 water ligands. we can say these are aqua ligands. Aqua बोलते हैं इसको. So 6 aqua ligands मतलब the hybridization will be sp3d2. sp3d2 मतलब copper in the plane, there will be 4 H2O up, 5 6 down, meaning it will be having the octahedral geometry. So the copper hydrated is having octahedral. Now it is treated with the hydrochloric acid. With the hydrochloric acid, it gets converted into CuCl4 2 minus. CuCl4 2 minus. Now what will be the geometry of this complex? Tetrahedral. Because what has happened is now the copper is bonded to 4 chloroligands, and that's why the hybridization has changed from sp3d2 to sp3. Now it is observed that the blue color of this hydrated cupric ion has changed to yellow color because there is a change in the geometry, there is a change in the approaching ligand, and because of that the color also changes. Clear? In short, to sum up, the color of any transition metal ion depends on the first and the foremost condition is the presence of unpaired electron. With the unpaired electron there is a possible DD transition. Now that excitation is to be remembered as DD transition. It also depends on the nature of the approaching ligand. Nature of the approaching ligand, and the color can also change when there is a change in geometry of the complex. Change in the geometry and the hybridization of the complex. So 4 major factors determining the color of any transition metal ion.
All transition elements show colors.
No, the one which will have the d electrons filled. Rest all shows color. Yes. Fe2 plus, Fe3 plus all have different colors. Fe2 plus is green, FeSO4 जिसको green vitriol बोलते हैं. ZnSO4 is white vitriol because of the absence of any unpaired electron. Mg S block है और S block का silvery white. S ब्लॉक में तो ट्रांजिशन होता ही नहीं है ना, दैट इज व्हाई दे आर ऑल सिल्वरी वाइट, लस्ट्रस होते हैं. बाकी जब हम वेरिएबल ऑक्सीडेशन स्टेट्स की बात करते हैं और अनपेड इलेक्ट्रॉन्स पॉसिबल है प्लस d ऑर्बिटल्स होंगे तो उसका कलर्स होता है. बाकी कोई भी एलिमेंट जिसका आयंस अगर देखोगे दे विल बी जनरली वाइट या कलरलेस. क्या गोल्ड का भी अगेन व्हेन वी टॉक अबाउट गोल्ड, सिल्वर, प्लेटिनम, पैलेडियम, दे आर ऑल ट्रांजिशन मेटल्स. तो उसमें डी का सबशेल है, डी का सबशेल है मतलब डी ट्रांजिशन होगा, डी ट्रांजिशन होगा मतलब दे विल हैव सम कलर. Clear? So that's the summary of the formation of the colored compounds. So that's given over there. Non-metals में vacant d orbitals होगा, d which are not filled. So उसमें जो है within the subshell excitation हो सकता है. So from the ground state it can go to the excited state. Now once it goes to the excited state there will be some geometry change, and because of that the unpaired electron can have the transition which is possible. अब उसके transition की वजह से it can have different colors. So generally S block का colors नहीं होता है because they have the fixed oxidation state plus they don't have any unpaired electron to excite. ठीक है, देख लो. हाँ, more than one unpaired electron. There might be a bigger difference in the energy gap. Based on that the absorption will differ. Absorption differ करेगा तो excitation और जो emission होगा color will differ करेगा. So that all depends on the unpaired electrons. Minimum one unpaired electron should be present for the excitation to be possible. Now ये excitation में there is a reverse case also where the lower has Eg and higher has T2G. Now ये जो मैंने बताया है this is on the assumption that it has an octahedral geometry. जब octahedral complexes होता है तो splitting इस तरह से होता है. यही चीज जब tetrahedral complex में देखेंगे ना ये splitting उल्टा हो जाता है. They are the names which are given to the energy levels. इसका एक फंडा है जो मैं बताऊंगा आपको. So complexes में when I talk about CuH2O6 in this octahedral geometry, the cupric will have this type of splitting. But when it changes to CuCl4 with the tetrahedral geometry, it will have the splitting which is Eg नीचे and T2G ऊपर. ठीक है, तो ये रिवर्स स्प्लिटिंग हो जाता है when the geometry changes. T2G में हमेशा 3 और Eg में हमेशा 2.
is the bonding between copper and water?
Bonding between?
Copper and water.
Complexes always have only one type of bond. Coordinate. The water is a neutral ligand. The ligands are those which will have the tendency to donate the lone pair. D orbitals. बताता हूँ मैं ये कैसे होता है. इसमें पेयरिंग होता है, फिर ऑर्बिटल्स. ये सारे सिर्फ डी ऑर्बिटल में थोड़ी है. देखो ना इसके कौन से ऑर्बिटल लग रहे हैं. sp3d2. हाँ, तो वेकेंट डी ऑर्बिटल मतलब नेक्स्ट वाला. तो ये 4s 4p के 3 और 4d के 2 ऐसे होंगे. इस तरह से वो कोऑर्डिनेट बॉन्ड्स बना सकता है. सो डी ऑर्बिटल्स में कॉम्प्लेक्सेस के फॉर्मेशन का रीजन ही ये है that they can have the bonding possible through the vacant d orbitals. ठीक है, so just look at the notes. The second point, the reason is being explained in detail. The presence of one unpaired electron and incompletely filled n-1 d orbitals. And the splitting is given. Next page पे वो mention wheel दिया हुआ है just for understanding. मतलब just in case a question comes that if an ion is absorbing yellow radiation, the possible color would be violet. So it is not accurate color which we will be getting, but somewhere near अगर color पूछा है तो you can directly understand from this mention wheel. 8.10 पे दिया हुआ है. And then finally 8.10 पे एक question है, देखो. Factors on which the color of a transition metal ion depends. First, the presence of incompletely filled d orbital or unpaired electrons in metal ion, which will be d1 to d9, excepting d10. The compounds with the configuration d0 and d10 are colorless due to the absence of unpaired electron. For example, if we talk about scandium 3+, what will be the configuration? 3d0, because scandium had the configuration of 3d1, 4s2, 3 electron निकाल दो, कुछ भी नहीं बचा. Again, this will be found to be colorless. So the compounds of scandium 3+ will be colorless because of the absence of any unpaired electron. Second point, there should be a dd transition which should be possible. Then the nature of groups, the anions or ligands linked to the metal ion. Type of hybridization in metal ion in the complex and the geometry. So hybridization and geometry combined you can say as one condition. Clear? उसके बाद कौन से colored है, कौन से colorless है, वो सब questions दिए हुए हैं. On the right 8.11 there is one question which is given at the end. Important है वो. Explain why is copper sulfate blue in color when dissolved in water but turns yellow when treated with concentrated HCl. Copper is blue when dissolved in water, but it changes to yellow when it is treated with concentrated HCl. So the main simple one-liner reason here is there is a change in the geometry and the hybridization when the copper in water is converted to copper with chloride ligands. ठीक है? So last में 7th point दिया हुआ है, देखो. Due to a change in geometry and hybridization of the complex, the color of the solution changes from blue to yellow. Next is catalytic property of d block transition metals. Most of the reaction which we have studied up till now, if you look at the catalyst, they will be from the d block elements. Can you name a few of them? V2O5 used in contact process. Nickel used in catalytic hydrogenation. AlCl3 is not D block. Palladium, nickel, platinum, palladium. Haber's iron with molybdenum. Yeah. Chromium के नीचे molybdenum, molybdenum के नीचे tungsten. Chromium in oxidation, that is one of the oxidizing agent. Even manganese, KMnO4 as an oxidizing agent. So they are actually the reagents, but catalyst mein many of the reactions have the use of D block metals as the catalyst. Now many of the D block elements we know are used as catalyst. So what is the function of the catalyst first of all? To speed up the reaction by decreasing the activation energy. To speed up the reaction. Secondly, a catalyst is that substance which will first participate in the reaction, will form an intermediate and then get regenerated. So if it participates in the reaction and forms an intermediate, it needs to have the variable oxidation state possible, because when it forms an intermediate and then gets regenerated, it is actually having a transition from one oxidation state to another. Now since the D block have the tendency to form variable oxidation state, they can behave as catalyst in many of the reactions. Secondly, the D block metals have a large surface area, due to which it can have the property of adsorption, and many of the heterogeneous catalysis works on the theory of adsorption, and adsorption basically is a surface phenomena. You need to have a large surface area. Thirdly, the D block metals have a surface area with the pores or the gaps in between them. Because of those gaps, they will have the property to attract the other gaseous molecules on the surface and form a bond between them. So जैसे कैटालिटिक हाइड्रोजनेशन में हमने देखा कि रानी निकल यूज किया था. निकल और हाइड्रोजन पहले फिजिजॉर्ब होगा, मतलब फिजिकली एडजॉर्ब होगा. उसके बाद H2 के मॉलिक्यूल्स विल ब्रेक इनटू hydrogen atoms. That hydrogen and nickel will form a hydride, a chemical bond, and that is nothing but chemisorption. So at higher temperature, the chemisorption will be favored. At lower temperature, physisorption is favored. So basically this is again based on the theory of adsorption. Is that clear? So अगर मैं generally बताऊँ तो if there are reactants A and B in the presence of a catalyst C, it is forming a product. What actually happens, the A and B react with the catalyst C, so it participates in the reaction, then it forms an intermediate, let's say A, B, C, and finally this complex would break down to form the AB product along with C getting regenerated as the catalyst. This is also how the enzymes work. So enzyme binds with the substrate to form the ES complex. That ES complex would break down to give you the product along with the enzyme getting regenerated. And the basis of all catalytic properties is to decrease the activation energy. Clear? So D block metals behave as catalysts due to what important reasons? Pehla, the presence of variable oxidation state. This is very, very important. The D block metals behave as catalysts because of the variable oxidation state. Then the presence of large surface area, due to which it has the property of adsorption, both physi as well as chemi, that depends on the temperature. Okay? And in the intermediate, they have the tendency to form complexes, and the complexes are formed due to the presence of vacant d orbitals. So since there is vacant d orbitals present for the transition metal compounds, there is possible formation of large number of complexes. Is that clear? ठीक है, तो मेन पॉइंट्स जो है आपको हर प्रॉपर्टी का याद रखना है. कैटालिटिक प्रॉपर्टीज ऑफ डी ब्लॉक इज ड्यू टू वेरिएबल ऑक्सीडेशन स्टेट, लार्ज सरफेस एरिया, इससे रिलेटेड एडसॉर्प्शन, और जो इंटरमीडिएट्स है दे आर बेसिकली जनरली द फॉर्मेशन ऑफ डिफरेंट कॉम्प्लेक्सेस. कॉम्प्लेक्सेस क्यों बनाता है? क्योंकि वेकेंट डी ऑर्बिटल है जो लिगेंड से इलेक्ट्रॉन पेयर को एक्सेप्ट कर सकता है. जैसे अभी हमने एक कॉम्प्लेक्स देखा CuH2O 6 So this complex actually binds 6 water ligands to the central metal ion, that is copper, and it will form an octahedral complex where the copper will be binded to 6H2O, meaning they will accept how many electrons? Copper binds to 6 H2O ligands, so they will accept how many electrons? 12. They will accept 6 electron pairs, which is simply equal to 12 electrons. So there will be 6 orbitals which will be required. So when we say sp3d2, they are actually the orbitals which have mixed and recasted to form equal energy hybrid orbital, which will accept the electron pair from the water as a ligand. Are you clear with that? So here I have also covered the property of the d block metal to form complexes, which in turn is related to the catalytic property as well. ठीक है? एक example दिया हुआ है of a reaction जहाँ पर catalytic property could be justified or explained. The reaction is between I minus plus H2O82 minus. I minus is iodide. What is H2O82 minus anion called? If you just add H plus to it, the formula of this compound would be H2S2O8. What's that? Perchloric is HClO4. Peroxy disulfuric acid ही तो है ये. रिडॉक्स में पढ़ा है हमने. दो एसिड्स सल्फर के हमेशा याद रखना. H2SO5. This is Carnot's acid. This will be Marshall's acid. Listen, this is something you should remember. H2SO4 is well known. ये भी भूल गए. Sulfuric acid. After that, remember it is peroxy sulfuric acid. Hence, the structure is also understood. Meaning, instead of OH, there will be OOH. Peroxy linkage आ जाएगा. Then H2S2O7 पता है? क्या सुना है? ओलियम. कॉन्टैक्ट प्रोसेस में इसी से तो सल्फ्यूरिक एसिड को बनाते हैं. अब ओलियम के बाद आता है H2S2O8 and this is peroxy ओलियम बोल सकते हैं या peroxy disulfuric acid. तो इसके स्ट्रक्चर में भी there will be OO peroxy linkage. आई बात समझ में? Always remember these two acids of sulfur, they are important. This is commercially called Carnot's acid and this is commercially called Marshall's acid. Remember by now, P block में काफी हेल्प मिलेगा. ये सारी चीजें रिपीट होगी ऑक्सीजन फैमिली में. ठीक है? Anyways, the reaction is between now the I minus and peroxy disulfuric acid का anion. Then on reaction it gives you I2 plus twice of sulfate, and if I balance it, it will be this. Now this reaction is catalyzed in the presence of ferric ion or ferric compound Fe3 plus. So if we look at the mechanism of this, what would happen? The catalyst will first participate in the reaction, will react to form an intermediate and then it will get regenerated. That's what the mechanism explains. So first step mein the I minus reacts with the ferric ion. Now I minus has a tendency to, what is I minus to I2 conversion? It's oxidation. So the Fe3 plus itself will undergo reduction to form Fe2 plus. Clear? मतलब what has happened over here, the ferric ion has oxidized iodide to I2 and itself undergone reduction. Now the Fe2 plus will react with the H2O82 minus and again will change to ferric along with the conversion to sulfate ion. So if I take the net reaction, what we do is common things are cancelled out. So if I cancel Fe2 plus, what is observed? It's an intermediate. So the D block elements act as the catalyst because of the presence of variable oxidation state, or in the presence of some ligand it can have the tendency to form complexes also, and the complexes is due to the presence of vacant d orbitals. दूसरी बात, if I see the other part, Fe3 plus is cancelled out, So a substance or the ion which is first consumed and then regenerated is acting as a catalyst. So Fe3 plus in this reaction is a catalyst, but Fe2 plus is nothing but an intermediate of the reaction. समझा? नेट रिएक्शन देखोगे तो डेफिनेटली वही आएगा जो हमने डिस्कस किया है. क्लियर है ये? समझा? ठीक है. नेक्स्ट इज मैग्नेटिक प्रॉपर्टीज. Magnetic properties. Now, when a magnetic field is applied to a substance, they have a tendency to either get repelled or attracted. Based on that, there are two types of behavior which is observed: paramagnetism and diamagnetism. The reason for paramagnetism is the presence of unpaired electron, and would have all the electrons which are paired. If the number of unpaired electrons are large, the attraction in the magnetic field is very strong, such that it acquires permanent magnetism. Such substances are called ferromagnetic substances. So ferromagnetism, we can say, is an extreme case of paramagnetism with more number of unpaired electrons. Simple enough. So the magnetic properties of any compound or ion depends on the presence of unpaired electrons. Unpaired electrons. So I can relate the substances which are colored
with magnetic properties
will always have magnetic properties, because the color and the magnetic properties both depends on the presence of unpaired electron. तो ये combine करके question आ सकता है कि ये paramagnetic है, color होगा या colorless होगा. So if it is paramagnetic, it has to be colored, and vice versa. If it is colorless, it has to be diamagnetic. So ये हमेशा याद रखना, magnetic properties and the color depends on the presence of the unpaired electron. So now, the strength of the magnetic property or the paramagnetism is identified by a formula given by Bohr. And the formula is called Bohr magnetron, which is given as root of n into n plus 2, where n is the number of unpaired electron. N is the number of unpaired electron. ये हम डिस्कस कर चुके हैं. And the unit we write is Bm. That is nothing but Bohr magnetron. ठीक है. अब इसमें क्वेश्चन किस तरह से आ सकता है? Let's say they give you an ion M2 plus with Z27. Calculate the magnetic moment. Now M2 plus is metal का divalent cation. Z27 दिया है, मतलब it is which transition metal? Feco, that is cobalt. So basically this is nothing but cobalt 2 plus. Question कैसे दिया है? Divalent cation और bracket में they have given the atomic number. With 27 we observed it to cobalt and 2 plus मतलब cobalt 2 plus. ठीक है. अब cobalt 2 plus का configuration बताओ क्या होगा? 3d7. 27 मतलब d7. ये सिंपल है. 27 है मतलब इसका d7 कॉन्फ़िगरेशन है. तो 3d7 4s2 में से 2 इलेक्ट्रॉन निकला तो 4s0, ये तो गया. अब 3d7 मतलब अनपेयर्ड इलेक्ट्रॉन कितने हैं? 3. 10 में से माइनस करो, सिंपल. सो 5 इलेक्ट्रॉन सिंगल जाएंगे और 2 पेयर होंगे, मतलब द नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स आर 3. देयरफॉर द मैग्नेटिक मोमेंट would be given as square root of 3 into 3 plus 2, that is square root of 15, which will be near to 16, and that's why the answer will be 3.9 something bm. This is how you solve the question of the magnetic moment. ठीक है. इसका एक शॉर्टकट भी है. Whatever are the number of unpaired electron, the answer will be that point something. No, it will be lesser than 4 ना. Root of 16 is 4, so 16 से कम है, and that's why जितने unpaired electron हैं उसका आंसर हमेशा उसके नंबर के पॉइंट पे ही आएगा. Similarly, 2 unpaired electron अगर हुआ तो the formula would have been root of 2 into, that is 4. So root 8 less than root 9, 2.83 आता है actual answer, but 2 point आया, 2 अनपेड इलेक्ट्रॉन 2 पॉइंट, 3 अनपेड इलेक्ट्रॉन 3 पॉइंट, 4 अनपेड इलेक्ट्रॉन 4 पॉइंट। तो आपको एक्यूरेट कैलकुलेशन की कोई जरूरत नहीं है। ऑप्शंस में 1 पॉइंट, 2 पॉइंट, 3 पॉइंट, 4 पॉइंट दिया है, आपको सिर्फ अनपेड इलेक्ट्रॉन देखने हैं एंड यू कैन मार्क द आंसर डायरेक्टली। दिस इज बोस मैग्नेट्रॉन। Thirdly, this particular formula is also called spin only formula. The reason is this depends on the spinning of the electron. That is why it is also called spin only formula. ठीक है? So we have discussed catalytic property, complexes due to the vacant d orbital, magnetic properties. Magnetic moment is strength of the paramagnetic compound or substance. उसी को मैग्नेटिक मोमेंट बोलते हैं। इट्स एक्चुअली एज गुड एज अ वेक्टर क्वांटिटी, दैट्स व्हाई वी आर कॉलिंग इट एज मैग्नेटिक मोमेंट। जो स्पिनिंग है उसका डायरेक्शन भी मैटर करता है, इसलिए इसको स्पिन ओनली फॉर्मूला बोलते हैं। हाँ, Fe अब कौन सा दिया है वो डिपेंड करता है। 2+ होगा तो 4 अनपेड इलेक्ट्रॉन तो 4 पॉइंट आएगा, एंड Fe 3+ होगा तो बिकॉज Fe 3+ मतलब 3d 5 हो गया ना, 5 मतलब वो 5 अनपेड इलेक्ट्रॉन से 5 पॉइंट, इसलिए आयन में फेरोमैग्नेटिज्म पॉसिबल हो जाता है। बिकॉज मैक्स अनपेड इलेक्ट्रॉन कितने हो सकते हैं? 5 ही हो सकते हैं, बिकॉज 6 ऑनवर्ड्स तो पेयरिंग शुरू हो जाता है, इसलिए आयन कैन हैव दैट मैग्नेटिक प्रॉपर्टी पॉसिबल। ठीक है, परमानेंट मैग्नेट में एक एग्जांपल हमेशा याद रखना, दैट इज अलनीको अलॉय। The commonest example of a permanent magnet is alnico, which is an alloy of aluminium, nickel, cobalt and iron. The property of d block elements to form interstitial compounds. Interstitial compounds. Now, when the lattice of the metal is observed, then the metallic atoms are joined together by what type of bond? Metallic bond. So in between the metal atoms there are few gaps or spaces. These are called interstices. Now these small gaps, or rather interstices, can be occupied by smaller atoms like hydrogen to form hydride, similarly oxygen to form oxides, boron to form borides, nitrogen to form nitrides, and so on. So these smaller atoms can occupy the available space or the interstice, and hence the compound which is formed is called interstitial compound. Now they are also called non-stoichiometric compounds, because when we talk about the examples of such type, the stoichiometry of the metal and the interstitial atom is not in a fixed proportion like the compounds, normal compounds which are observed. जैसे zirconium is written as ZrH 1.57, vanadium का hydride is written as VH 0.56. It means that for every mole of zirconium, the H is occupied as 1.57 times. It is not in a perfect whole number ratio like the normal compounds have. जैसे कैल्शियम का हाइड्राइड will always be CaH2, सोडियम का हाइड्राइड would be NaH, 1:1, 1:2, 2:3, इस तरह से compounds बनते हैं. But here, since the interstices are differing due to the atomic sizes of the transition metal, the sizes also will vary, and hence the proportion in which the atoms would enter, the smaller atoms, that would also be variable. Hence the interstitial are also called non-stoichiometric. And this is basically formed by which block elements? And F block. D block and F block. If you remember, hydrogen chapter में we had studied about hydrides. Hydrides 3 टाइप के होते हैं. Perfect, very good. S block के जो hydrides होते हैं, they are called saline hydrides because they are salt-like या ionic in nature. ठीक है, the hydrides of P block.
उसके अंदर भी 3 टाइप होता है, एक इलेक्ट्रॉन प्रिसाइज, इलेक्ट्रॉन डेफिशिएंट एंड इलेक्ट्रॉन रिच.
and that depends on the groups of the p block. उनको covalent hydrides बोलते हैं because the type of the bond is covalent. Electron precise. पहले deficient बाद में rich. Perfect. और डी एंड एफ ब्लॉक जो हाइड्राइड्स बनाते हैं वो आपके नॉन स्टोइकियोमेट्रिक हाइड्राइड्स बोले जाते हैं. सो जस्ट रिमेंबर द रेफरेंस ऑफ द हाइड्रोजन दैट विद द हाइड्रोजन डिफरेंट ब्लॉक एलिमेंट्स फॉर्म द डिफरेंट टाइप ऑफ हाइड्राइड्स. सो एस ब्लॉक जो है वो सलाइन हाइड्राइड्स बनाते हैं एंड द टाइप ऑफ द बॉन्ड इज आयोनिक. द बेस्ट एग्जांपल इज Na+H-. पी ब्लॉक जो है वो हाइड्राइड्स बनाते हैं जिसमें we can have CH4, बोरॉन का BH3 एंड नाइट्रोजन का NH3 या फिर H2O या फिर HF. तो ये इलेक्ट्रॉन प्रिसाइज हाइड्राइड्स बोले जाते हैं बिकॉज द ऑक्टेट इज कंप्लीटेड. ये डेफिशिएंट होंगे बिकॉज ऑफ लेस देन 8 इलेक्ट्रॉन्स और यहाँ पे लोन पेयर है, दैट इज व्हाई दे आर कंसिडर्ड एज इलेक्ट्रॉन रिच. ठीक है, बट डी एंड एफ ब्लॉक फॉर्म दिस टाइप ऑफ हाइड्राइड्स व्हिच आर कॉल्ड नॉन स्टोइकियोमेट्रिक या मेटेलिक हाइड्राइड्स बिकॉज नाउ द टाइप ऑफ द बॉन्ड हियर इज मेटेलिक बॉन्ड. बोलो.
So in which one is it that hydrogen doesn't make a bond? It's only an overlap of 99.
वो तो नाइट्रोजन आटम के अंदर और ऑक्सीजन आटम के अंदर नीचे जा रहा है.
हाइब्रिडाइजेशन पूछ रहे हैं.
pH3 और उस सब के लिए.
You are clear. Sometimes hydrogen doesn't bond. It's only a
simple overlap.
simple overlap.
That is for hydrides of group 15, 16
After
and
nitrogen oxygen.
that is related with Drago's rule. वो hybridization और बाकी properties को explain करेगा along with basic strength.
हाँ basic.
तो यहाँ पे तो हम सिर्फ अमोनिया की बात कर रहे हैं, तो अमोनिया में तो प्रॉपर ओवरलैप है ही, मतलब हाइब्रिडाइजेशन. ठीक है. सो इंटरस्टिशियल कंपाउंड्स की प्रॉपर्टीज की अगर बात करें तो इफ आई कंपेयर द इंटरस्टिशियल कंपाउंड विद द प्योर मेटल, मतलब आयन जब प्योर है और आयन जब इंटरस्टिशियल कंपाउंड बना रहा है तो उनकी प्रॉपर्टीज में क्या डिफरेंस आएगा. फर्स्ट, हार्डनेस. विच वुड बी हार्डर? Pure metals are generally soft and they are not used in the commercial application directly. They are used in the form of alloys or in the form of some interstitial compound because pure metal ka hardness could be enhanced by adding some smaller atom. So ये fill करने के बाद the hardness जो है of the pure metal would be increased. So interstitial compounds are hard as compared to pure metal. In fact, some of the compounds become so hard that its hardness can be compared with the hardest substance, which is diamond. तो इसके बोराइड्स और कार्बाइड्स, कार्बन के साथ ये कार्बाइड्स बना सकते हैं. इनके कार्बाइड्स इतने स्ट्रॉन्ग हो जाते हैं कि उनका हार्डनेस कैन बी कंपेरेबल टू डायमंड. सो आयन में कार्बन ऐड करते हैं, वो कार्बन कहाँ जाता है? इंटरस्टाइसेस में जाता है. और स्टील जो है वो एक्चुअली एक इंटरस्टिशियल कंपाउंड का एग्जांपल हो गया. ठीक है, ऐसे बहुत सारे एग्जांपल्स हैं. तो जनरली कमर्शियल एप्लीकेशन में प्योर मेटल्स हार्डली कहीं पे भी यूज होता है. आइदर अलॉयज यूज होते हैं या फिर इंटरस्टिशियल कंपाउंड्स यूज होते हैं. ठीक है, बिकॉज ऑफ द हार्डनेस गेटिंग एनहांस द मेल्टिंग एंड बॉइलिंग पॉइंट वुड ऑल्सो इंक्रीज. But if I talk about the metallic character, will it be changed?
It might be.
The metallic character is due to the mobility of the electrons. By adding the interstitial atoms, is the mobility changed?
Yeah.
Pieces of field, so it will decrease.
Now, since only few of the or smaller spaces are being occupied, the change in the metallic conductivity is small. So it is as good as negligible. So अगर हम कंपेयर करें तो डेफिनेटली वो डिक्रीज होना चाहिए क्योंकि मोबिलाइजेशन जो है वो अफेक्ट हो जाएगा बिकॉज ऑफ द ऑक्यूपेंसी ऑफ द इंटरस्टिशियल एटम्स. बट उसका जो चेंज है वो इतना ड्रास्टिक नहीं होता है, इसलिए हम ऑलमोस्ट बोलते हैं कि द मेटेलिक कंडक्टिविटी रिमेन्स दी सेम. थियोरेटिकली डेफिनेटली वो चेंज होना चाहिए बट चेंज इतना कम होता है कि हम उसको इग्नोर करते हैं. ठीक है. दूसरा, जो प्योर मेटल है वो इनर्ट रहेगा. ठीक है, विद सम लिगेंड इट वुड हैव द रिएक्टिविटी पॉसिबल. तो यहां पर भी इंटरस्टिशियल कंपाउंड जो है वो भी केमिकली इनर्ट हो जाते हैं. ठीक है, तो ये कुछ प्रॉपर्टीज हैं ऑफ द इंटरस्टिशियल कंपाउंड्स व्हेन द इंटरस्टाइसेस आर फिल्ड बाय दी स्मॉलर एटम्स. ठीक है. नेक्स्ट, द ट्रांजिशन मेटल्स हैव द टेंडेंसी टू फॉर्म लार्ज नंबर ऑफ alloys. Now alloys are formed due to mixing of two or more metals along with non-metals. Now if two metals are to be mixed, it has to be mixed in its molten form or molten state. And alloys आप देखोगे तो generally transition metal ही बनाते हैं. बाकी किसी ब्लॉक के alloys इतने ज्यादा known नहीं है या बनते ही नहीं है. Now reason behind the formation of alloys ये समझते हैं. The simple example of alloy we can relate it to is brass. Brass is an alloy of cousin, that is copper and zinc. मतलब क्या होता है, कॉपर का एक लेटाइस ले लो जिसमें कॉपर के एटम्स हैं, एंड जिंक का एक लेटाइस ले लो जिसमें जिंक के एटम्स हैं. ठीक है, अब इन दोनों को मिलाओगे तो यू विल गेट अ रिजल्टेंट अलॉय in which some of the atoms of the copper would be replaced by zinc. So let's say we have copper, zinc and so on. This is how the alloy would be formed. Now the replacement of the metallic atoms are possible because of what? The copper can replace the zinc and occupy. Interstice कहाँ? ये पूरा एटम निकाल के उसकी जगह ले रहा है. ये इंटरस्टिशियल से रिलेटेड नहीं है. अब अगर उसको रिप्लेस करना है तो उसका साइज सेम होना चाहिए. और हमने ट्रेंड देखा है एटॉमिक आयोनिक साइजेस का, जिसमें हमने देखा कि स्कैंडियम टू क्रोमियम डिक्रीज होता है, फेकोनी ऑलमोस्ट कांस्टेंट होता है, और कॉपर और जिंक में जिंक थोड़ा सा लार्जर हो जाता है. बट फिर भी अगर कंपेरेबल साइजेस की बात कर रहे हैं तो जिंक एंड कॉपर का साइज काफी कंपेरेबल है, इसीलिए वो एक दूसरे के साथ मिक्स करके अलॉयज बना सकते हैं. एंड द रेंज इन विच द साइजेस शुड डिफर शुड नॉट एक्सीड 15 पिकोमीटर. ये कंडीशन है. 15 पिकोमीटर के रेंज में अगर डिफरेंस है तो उनका अलॉयज करना पॉसिबल होता है, जो कि एक प्रॉपर्टी है डी ब्लॉक में, जहां पर इफ यू कंपेयर दी एटॉमिक साइजेस द वेरिएशन वुड नॉट बी मोर देन 15 पिकोमीटर. और जहां ये कंडीशन ट्रू है वहां अलॉयज का पॉसिबल फॉर्मेशन हो सकता है. तो मेन कंडीशन फॉर द फॉर्मेशन ऑफ अलॉयज इज सिमिलर एटॉमिक साइजेस विद अ रेंज ऑफ नॉट एक्सीडिंग 15 पिकोमीटर. समझा?